It is 4:36 now, 4:36 p.m. and 16 of you are present as I see. Okay, but let me start. We are discussing transient stability. Okay, equilibrium criterion. How equilibrium criterion can determine the transient stability or assess the transient stability of the system of a generator connected to infinite bus. This we have seen. And then we have started to discuss how stability may be improved. Okay, so these are the points I shall be discussing. So already I have discussed this one: high inertia and low reluctance. These are uh, you see that these are things that will improve the transient stability of a system of a generator, because high inertia means rotor will be heavy and variation of delta will not be very easy. Okay, variation of delta will take time. A large force will be needed to change the angle, and therefore this machine will be inherently more stable. Okay. Then low reluctance will increase the peak of the power angle curve. If the peak of the power angle curve is increased for the same amount of active power, or for the same amount of power delivered by the generator, operating angle, initial operating angle, that means delta zero, will be smaller. If delta zero is small, then the machine will have a wide range of delta through which it can swing. The machine can swing through a larger angle, and uh, since the it can swing through larger angle, more time will be available for the control system to be applied for improving the stability, for maintaining the stability. That's why low reluctance of the system will help in improving the transient stability of the generator. Okay. Then we have started this. We simply mentioned this, but not increase, not discuss all these things. Any measure to increase steady state stability, that also will increase the transient stability. So now you have to see how steady state stability may be improved. So anything you do that will increase the steady state stability will improve the transient stability as well. So you must let us first see how which methods will improve the steady state stability, and then how the same method may improve the transient stability of the system as well. What are the methods? Methods are obviously how steady state stability may be improved. If you have a steady state stability is for that you can say that power, stability limit is that power or that angle. If you talk in terms of angle, then it is equal to 90 degree. If we talk in terms of power, then it is the peak of the power in your car, and it is fixed. Steady state stability limit, already we have discussed that it does not depend upon the current operating condition. It is independent of the operating condition of the machine, and steady state stability limit for a system is fixed. What is this fixed limit? That is corresponding to delta equal to 90 degree, assuming that there is no saliency of the generator or there is no resistance of the system. Both are to be considered actually. Okay, there is no resistance at the same time. There is no saliency of the generator. Generator is cylindrical rotor type. Okay, so under this situation, peak of the power angle curve occurs at delta equal to 90 degree, and the corresponding peak. That means for delta equal to 90 degree, it is a peak, and the peak power is the limiting power for steady state stability. So this therefore uh, we have to see how this peak of the power angle curve may be increased, because if the peak of the power angle curve is increased, then it indicates that the stability limit also is increased. More power can be delivered means limit for stability is higher. Okay, and how you can increase the peak of the power angle curve? Increase of E and V. E means the induced EMF, that means the internal voltage of the generator. or the generated voltage of the generator, and V is the terminal voltage, or V is the infinite bus. Now the question is, how much can we increase E or D? Obviously, there is some limit. Why there is some limit? Because it depends upon the machine you are dealing with. It is a certain maximum field current limit, and field current you cannot actually vary in the very through a range that is not required for the system now. Why I am saying this? Because you see that generators, it is customary. It is, you can say that it is a requirement of the system. Considering everything, it is a requirement of the system because you have to control the voltage of the system. So if you want to control the voltage of the system, then the method that is employed for maintaining the system voltage within the specified limit, or maintaining the voltage regulation within the specified limit. Maintaining the voltage regulation means actually variation of voltage will be limited very by a very small amount. Okay. So for that reason, what has to be done? Terminal of the generator has to be kept constant. This is needed for any system. The terminal voltage has to be kept constant. So if you maintain the terminal voltage constant, means generator terminal voltage constant, then how much you can increase the peak of the power angle curve? You cannot go beyond that. You cannot increase the peak of the power angle curve to such a value that, or you cannot increase the excitation current, field current to such a value that terminal voltage is becoming greater than the normal value, greater than the said value. That will not be permissible. Therefore, what best you can do for maintaining the, for improving the steady state stability limit, what you can do, you have to maintain the terminal voltage constant and accordingly adjust the field current such that corresponding induced EMF is sufficient to maintain the constant terminal voltage that is required. That means you cannot increase the value of E to a very large value. That is limited by the uh, operational requirement of the system. And what is the operational requirement? Operational requirement is that at the terminal of the generator, you must maintain the voltage constant. Therefore, you adjust the value of E rather by changing the field current such that the terminal voltage of the generator remains constant. This is needed, and if that can be maintained, then you can say that the steady state stability will be maintained properly. Proper value of power transfer limit may be obtained for this system. Okay, then so this is regarding these things, how much can we increase the value of E and V? And V, if this is the terminal voltage, this has to be kept constant. If this is the infinite band voltage, we have nothing to do. This voltage is always constant. So E is the induced EMF. How much you will be controlling this induced EMF? That much that is required for maintaining the terminal voltage constant. So that has to be done. That means field current must be variable. You must be able to vary the field current such that the terminal voltage at any load is constant. If you don't have the field current variation facility, or if you cannot vary the field current depending upon the terminal voltage, then what will happen? At heavy load condition, terminal voltage will fall. As a result, peak of the power angle curve will also fall. So we shall not allow to do that. Rather, we shall be adjusting the field current. We shall be varying the induced EMF. As a result of variation of field current, induced EMF will vary. So we shall be varying the induced EMF such that the terminal voltage remains constant. This is the requirement, and if this can be done, you can see that uh, in, induced EMF will be uh, having the required value. Okay. Then these are the method for improving the transient steady state stability, you can say. And therefore, they will improve the transient stability as well. How? Because if the proper value of the peak of the power angle curve is maintained, then if we do not allow the voltage to dip, If you do not allow the voltage to drop, then what will happen? The proper value of the peak of the power angle curve will be maintained. As a result of what? For the given power to be transmitted, value of delta will be smaller. And if the value of delta is smaller, as I have already mentioned, you will have a greater flexibility. You will have more time through which delta will swing. For a disturbance, delta will be able to swing through a longer period, through a wider range of angle, and that will give the controller more time between which the controller can adjust the control parameters such that the transient stability of the system is maintained. Okay, this is therefore how the improvement of steady state stability will help to improve the transient stability as well. Now, what are the other methods by which the peak of the power angle curve curve may be improved, or by which the steady state stability may be improved? These are the methods that will actually reduce the value of x. This is not reading x, this is the reducing the value of x. It is a reactance. You have to somehow reduce the transfer reactance. We call it transfer reactance because this is the reactance between the generator and the infinite bus. If we determine the stability of the generator connected to infinite bus, then it is the reactance between the generator terminal and the infinite bus. Or therefore, this is the transfer reactance between generator and infinite bus. So, how to reduce this reactance? X means inductance has to be reduced, means series reactance. This reactance basically is the series reactance. Not we are not talking about the shunt reactance now. Okay, we are not talking about the line charging capacitance here. We are reducing the value of X means reducing the value of the series impedance. Okay. Then how to do this? One method is to use the bundle conductor. Now the question is, do you know what is bundle conductor? Because it should have been studied by you in the previous semester. Now tell me whether you know about bundle conductor or not. Do you know what is bundle conductor? How many of you know regarding a bundle conductor? What is a bundle conductor? Anybody who knows about bundle conductor? What is bundle conductor? Ankit, Ankit Joshwal, can you tell me what is bundle conductor? Have you heard of it? Ankit Joshwal or Ali Hamzan? Do you know?
Yes, sir. More than one conductor in a single phase for transferring
Uh,
power.
More than one conductor. How they are placed?
Sir,
How they are placed? More than one conductor in one phase, but how these conductors are arranged? Do you know that?
sir, in a proper in a square means four conductor in a phase or more than that.
That means two conductor per phase, three conductor per phase, four conductor per phase, like that. Okay, bundle
Yes, sir.
conductor means a bundle of conductor basically. Each phase will have more than one conductor. Okay, and there is a difference between. Do you know the difference between the stranded conductor and bundle conductor? There is another thing called the stranded conductor. What is the difference between stranded conductor and bundle conductor?
Sir, in case of bundle conductor, they are placed some part apart. They are
Hmm.
have some distance between the specific distance between the two
Okay.
conductor. But in the standard conductor, uh, they are literally beside one another. There are no gaps such as that
Okay.
between conductor.
Actually, sorry, um, stranded conductor. they are actually spiral. Okay, a group of conductor, they are spiral together. Okay, so each conductor is above the other conductor like this, and they are spiral together. And what is the main purpose of spiraling this in this way? Only to increase the flexibility, such that all these subconductors. That means each conductor is composed of a number of conductors. How many conductors may be there in the strand, in a single strand conductor? Maybe 6 plus 1, that means 7 conductor, maybe 12 plus 6 plus 1, that means 19 conductor, like that. That means inside there will be one conductor, surrounding that there will be 6 more conductors, surrounding that there will be 12 more conductors. In this way, conductors are arranged, and all these conductors are electrically touching each other, they are spiral together. The main purpose is that inside there is a, it is called ACSR, aluminum conductors, steel reinforced. Inside there the steel conductor, outside the steel conductor there are aluminum conductors. Okay, therefore this is that these conductors are so arranged because steel will increase the tensile strength, aluminum will increase the conductivity. Okay, aluminum has low tensile strength, so all aluminum will have a lower tensile strength. That's why in a CSR conductor, which is a bundle conductor, you will have a number of conductors together, where the innermost conductor will be steel conductor. Sometimes where the more number of strands are added, then more number of steel conductors may be added together. Okay, so this is standard conductor. And bundle conductors are different from standard conductor. Actually, in case of bundle conductor, each conductor may again be a, or will again be a standard conductor. So in case of bundle conductor, conductors, that means the subconductor, each phase will have more than one conductor. More than one conductor means number of conductors may be 2, number of conductor may be 3, number of conductor may be 4, maybe 6, maybe 8, like that, depending upon the voltage level. Higher the voltage level, more are the number of conductors per phase. More are the more are the number of conductors in each bundle. Okay, if the higher transmission voltage, number of conductor in the bundle increases. Okay, and what is the purpose of using this bundle conductor? Now, can you tell me why conductors are bundled? What is the basic purpose? What is the main purpose of using this bundle conductor? Who can tell me? What is the basic requirement? What is the main purpose for which the bundle conductors are used?
Sir, to sir, to increase radius.
Effect.
To increase
corona.
radius. Radius
Sir,
actually will not increase, other we can
sir, to
increase
reduce
the
resistance
effective radius. And therefore the corona will be reduced. Corona effect will be reduced. Now, corona means basically what will happen in corona? Corona, basically when the potential gradient at the surface of the conductor crosses a certain limit, and that means crosses the breakdown limit of the conductor, breakdown limit of air, breakdown strength of air, then the air surrounding the conductor is ionized. As a result, they will be actually consuming power. That this ionization will require power, so it will be consumed from the generator, from the system. So air will be ionized. As a result, there will be loss of energy, and effective diameter of the conductor will increase, and this is not a desired situation. Okay, so this is called corona. So basic purpose of using bundle conductor is to avoid this corona, is to skip this corona. How? Because if you obviously if you can increase the diameter of the conductor, then potential gradient will be reduced. Okay. So using bundle conductor as if we are increasing the effective diameter of the conductor. So if diameter is increased, effective diameter is increased, why this corona effect will be reduced? Why corona will not start at the applied voltage if you have larger cross section of conductor. Can anybody explain why this will happen? What is the relation
Sir,
between the
the
occurrence of corona and diameter of corona?
electric field is inversely proportional to the radius. E is inversely proportional to 1 by r. So effective radius increases, so the electric field reduces. Maximum electric field.
Basically, what happens? Obviously, if you write in terms of the equation, okay, mathematical equation, then obviously it is dependent upon the radius. Yeah, actually, what happens? Actually, this is the charge density that is responsible for the occurrence of corona, that is responsible for the potential gradient. Okay, so basically, when you are actually using bundle conductor, then what is happening? You are using a number of conductors which are separated from each other. So when you are using the number of conductors which are separated from each other, so you are actually increasing the uh, uh, you can say that increasing the periphery of the, that means the overall the outer diameter, basically the sorry, um, where the charge actually resides, they reside at the surface of the conductor. So effective surface area increases when you are actually using the bundle conductor. Say using the same volume of conductor as you have used in this two or three conductors in the bundle. If you use a single conductor which is actually a single conductor of which are not separated from each other, a solid conductor is used. In that case, the effective surface area will be smaller. That's why using the same conductor volume, you can say that same conductor material, if you use more number of conductors which are separate from each other, then effective surface area increases. Therefore, it is always better to use bundle conductors where more than one conductors will be connected in parallel. Okay, and therefore you will see that if you had used a single conductor who actually was say who actually was using, which conductor was actually using the same conductor material, same volume as used by the total number of conductor in the bundle. In that case, the effective radius would have been smaller, effective surface area would have been smaller. But by using bundle conductors, okay, that means the number of conductor, you are actually increasing the effective surface area. As a result, charge density as the surface of the conductor decreases, and this helps in reducing the corona. So the main purpose of using bundle conductor is not stability, is not the improvement of stability. It is rather improvement of performance of the conductor in connection with the occurrence of corona. So to avoid corona, we shall be using the bundle conductor in high voltage system. Okay. Always the higher the system voltage, more conductors will be used in the bundle. But as a result of using this bundle conductor, we shall be actually having effective increased radius of the conductor, as a result of which total inductance will be reduced, and the if the inductance is reduced, that means the series reactance of the conductor will be reduced, and if the series reactance is reduced, then obviously the peak of the power angle curve will reduce. So in this way, using bundle conductor will help to improve the steady state stability limit, and this also will help to improve the transient stability limit, because any method that will actually improve the steady state stability limit will improve the transient stability limit. Why? Already I have mentioned this point. The basic reason is that for the same amount of power to be transferred, if the peak of the power angle curve is higher, delta value will be lower. This is how the improvement in steady state stability will help improvement in the transient stability as well. So bundle conductor therefore is one method by which the steady state stability limit may be improved, though the basic purpose of using bundle conductor is not to improve the stability. The basic purpose is to avoid corona. But improvement of stability limit, that means reduction of series reactance, is actually, you can say, it is as a byproduct we are getting this. Okay, so this helps us in maintaining stability as well. Another thing is the series capacitance. Sometimes you may be using series compensation. That means the line reactance is there, so you will be using capacitor in series with the line. In that way, you will be reducing the total reactance, that is transfer reactance between the generator and infinite bus, that may be reduced. Could you get it? That means by using series capacitor with the transmission line, you can also reduce the value of system reactance, system series reactance. But there are some problem, because whenever you have some capacitor in series with the conductor, then that capacitor is a lumped reactance. Okay, that means, say you have a conductor, okay, you have a transmission line, then you have connected a capacitor in series with the line, and then say another section of the line. Right. Then what will happen? Before the capacitor, system reactance is all inductive reactance. After the capacitor, there will be drastically reduced value of reactance. So we measure the total reactance after the series capacitor, then drastically there will be reduction in the effective capacity, effective reactance, because before capacitor, okay, this capacitor terminal are A and B. Terminal A is connected in one side, terminal B at the other side. From the generator and say you have a total, you have in the, you have a transmission line, and then terminal A of the capacitor is connected. Then on the other end, terminal B, another line is connected. And the problem is that when you are at the end of A, when you are at end A, that means before the series capacitor, then total reactance, say from the generation into the input of the capacitor, there it is the inductive reactance. But if you cross the capacitor, then it is the inductance of the line plus the capacitance of the line. Drastically, the reactance value will decrease. Now you see that, assume that a fault is occurring at the terminal of the capacitor at end A. So a current will be flowing. What will be that current? It is the voltage divided by total reactance will be the current. But if a fault occurs on the other end of the capacitor at end A, at end B, then the fault is occurring somewhat at the far end of the capacitor. Okay. So side A is closer to the generator, but side B is uh, some somewhat apart from the generator. Distance is more, but if the fault occurs before the capacitor, then fault current will be less than the fault current that will be appearing in the system if the fault occurs on the other end of the capacitor. That means for a distant fault, current will be higher than for a nearer fault. This is a very problematic situation. Why this is a very problematic situation? Because when we use protection system for transmission system from transmission line, then we actually set our protective devices depending upon the fault current. If the current is less, we assume that fault is far away from the generator. If the current is higher, fault is closer to the generator. But this concept will actually be, you can say that it will be proven to be false if you um, uh, it will, if you consider, if you connect a capacitor in series with the transmission line. Therefore, the protection of the transmission lines becomes a bit difficult if series capacitors are used. This is one problem. Another problem is that if the fault occurs on the other end of the capacitor, then the fault current will flow through the capacitor. Now, capacitor is a lumped capacitors. Okay, lump impedance is there. If high fault current flows, because if the fault occurs on the other end of the capacitor, reactance will be less, then current will be very high. If that high fault current flows through the capacitor, there will be a large voltage drop across the capacitor. So protection of the capacitor again becomes a problem. So protection of the lines becomes a problem because of the flow of heavy fault current. Protection of the line also will become a protection of the capacitor also becomes a problem in this case. Could you guess the, could you understand the point? What I wanted to explain? Why connecting series capacitor creates some problem? These are the two issues I have mentioned. So could you understand these two issues? Why the protection of transmission line will be a problem first, and then why the protection of capacitor itself becomes an issue? Are these 2 points clear to you or not? Bolo.
Yes, sir.
Okay. There is another problem that is called the synchronous resonance. Actually, these capacitors are connected in series with the transmission line. Then sometimes, because of the flow of subharmonic current means actually in transmission system there may be harmonic current flowing in the system. Okay, generally higher harmonic current will flow. That means the second harmonic, third harmonic, fourth harmonic. These are the harmonic current. Multiplication of frequency. Consider. Okay, if 50 is hertz is the fundamental current, then 100 hertz is the second harmonic, 150 hertz is third harmonic. Like this, generally in power system, even harmonics are not present because of the symmetry of the waves, and odd harmonics will be present. Third harmonic, fifth harmonic, seventh harmonic. That means 150 hertz in 50 hertz power system, 250 hertz, then fifth harmonic, 350 hertz, seventh harmonic like this. But sometimes there may be the flow of subharmonic current as well. That means it may so happen that the harmonics which are less than 50 hertz, these are subharmonic. These currents also may flow. Okay, and because of the presence of the series capacitor, this capacitor may form some resonating circuit in the system with the inductance of the system. The inductance is already there and the capacitor is there. Because of the flow of some harmonic current, there may be formation of series resonance. And if series resonance occurs at those subharmonic current, okay, this subharmonic current, if they flow through the system, some lower, very small current may flow, okay, through the system. But if this current, because of the flow of this current, that means because of the flow of this current of this frequency, if resonance occurs, then obviously this current, the subharmonic current, will actually increase because resonance is occurring. It will be multiplied, it will be magnified, and the torque will be produced corresponding to this harmonic. As a result, there may be product produced, the torque is produced of this harmonic, then there will be oscillation of the generator rotor. Okay, not only the generator rotor, you may now have to consider the oscillation of the generator rotor, which is again coupled to the exciter. Exciter may be a different uh, generator. This so exciter rotor may also be coupled with a generator shaft, as a result of which it may so happen there that subharmonic current may create a resonating circuit, may create resonance in the system, and that subharmonic oscillation, if they are matching with the natural frequency of oscillation of any of the rotating part of the system, including the exciter, generator, shaft, and turbine, everything, then this may cause a great damage to the generator, turbine, and exciter. Okay, and there had been situations when, because of the subharmonic current, a great damage to the generator has occurred. There are actually evidences in the past where, because of the installation of the series capacitor, problem occurred in the generator shaft. Okay, generator shaft have broken. Okay, this has happened in the past. So this type of problem may be actually happening, occurring if series capacitors are used. So if series capacitors are used, they are very they actually offer very good method for reducing the system reactance to reduce the peak of the power angle curve. Okay, they are very much helpful in increasing the peak of the power angle. Okay, but the problem is that series capacitor introduces a number of problems. What are these problems? Problem is the protection of the line itself where the series capacitor is connected. Second problem is the protection of the capacitor itself because a large voltage will be dropped across the capacitor because of the flow of fault current. And third problem is that the presence of series capacitor may create the problem of subsynchronous resonance due to which the generator may be damaged in the long run. Okay, if somehow the resonance is created at subharmonic frequencies. So series capacitors are not that popular in power system. Rather, people actually rather use shunt capacitors because shunt capacitors do not create this type of problem. So shunt capacitor also will help improving the stability. How? Because shunt capacitor will help in maintaining the system voltage. And if the system voltage is maintained, as we have discussed here, if the system voltage is properly maintained, then you see that peak of the power angle curve will also be maintained. As a result, stability of the system will be maintained. But obviously, if the series capacitor can be used, then the impact of the series capacitor obviously is higher, is larger because peak of the power angle curve can be directly increased because of the drastic reduction in the value of series impedance. But it has some disadvantages. These disadvantages I have mentioned, and therefore series capacitors they are nowadays used because all these problems also again maybe there are methods to overcome this. That means there are methods to give a protection for series capacitor. There are methods to there are that means protective system how for keeping the occurrence of resonance. Okay. Again, there are protective system that will take care of the presence of capacitor in the system while protecting the transmission lines. This will be required and then only series capacitors may be used. But instead of using series capacitor, if you use shunt capacitor, again you can increase the peak of the power angle curve. You can improve the stability by using the shunt capacitor as well because shunt capacitor will maintain the voltage of the system. As a result, they will help in increasing the peak of the power angle curve and hence they will help in improving the stability of the power system. Okay. Then there are other methods. These are the methods for improving the steady state stability and as a result improving the transient stability as well. But now let us come to other points where the transient stability will be maintained or be improved directly. One is fast fault clearance. Okay, fast fault clearing. What is fast fault clearing? You will be if you remember we have mentioned regarding the critical clearing angle. Okay, critical clearing angle. You have to for each fault there is a fault clearing angle. Okay, if you clear the fault, that means if you remove the faulty part from the healthy part of the power system before that critical angle is reached, then it will be possible to maintain synchronism. It will be possible to maintain transient stability of the power system. So for that, the protective system has to be very far. That means relays and circuit breakers to be used for protecting the transmission system, to be used for protecting the power system components are to be very fast. Okay, so first fault clearance therefore will improve the transient stability. Then auto reclosing feature. The circuit breaker actually this is basically a feature of the circuit breaker that will help improving the stability of the power system. So auto reclosing feature means actually since you have not studied circuit breakers, you will not be understanding this very much to the full extent now. But still, let me discuss regarding this issue. What is auto reclosing feature? That actually what happens in power system, fault will always occur. And where the fault will occur? Because the transmission lines are bare conductors. We use bare conductors in our transmission lines. Then transmission lines have the most probable location for the occurrence of. Okay, because where conductors are used. But of the say uh, faults taken that are happening in power system, you can see that at least 80% of these faults are transient in nature. What do we mean by using the term transient fault? That means 80% of the fault at least are transient in nature. By the term transient fault, we mean that actually fault are such that they have just occurred, and if you somehow can de-energize the transmission line for a short while and re-energize it, then this fault will go automatically. This is the nature of most of the fault. At least 80% of the faults are of this nature. And why these faults occur? These faults basically occur uh, because of the deposition of dust particle on the surface of the porcelain insulator. Because you know that the overhead conductors they are hanging from the porcelain insulator, and porcelain insulators are actually held by the cross arm in the transmission tower. So the transmission tower they hold these porcelain insulators. Below the porcelain insulator, you have your conductor. So if we use disc type discs insulator or string insulator rather, then you have the string or you have the disc hanging from the cross arm, and below which the conductors will be tied with the porcelain insulator. Now, it may so happen that because of the deposition of dust particle on the surface of the porcelain insulator, the resistance between the conductor and the tower finally, which is grounded, resistance between the conductor and then to the cross arm, because cross arm is connected to tower, to the cross arm will be reduced. Why? Because dust particles are deposited here and the tower is finally grounded. So it may so happen that the resistance sometimes, particularly at foul weather condition, this leakage resistance between the conductor and the tower will become much small. And as a result, there may be the flow of current. This path may be ionized from the conductor to cross arm. There may be ionization totally from between this space, and current may flow from conductor to tower, means conductor to ground, creating a situation where a fault is occurring between the conductor and the ground. Okay, but the nature of this type of faults are such that these faults are basically arcing fault. An arc will be created from the conductor to cross arm through this dust particle at the surface of the tower of the porcelain insulator. Now, if you can de-energize the conductor for a short while, then this fault will automatically go. That means if you de-energize it and then re-energize the conductor, then the fault will automatically go. Now the situation is such that say a fault is occurring and you have a protective system which is not auto reclosing type. What is auto reclosing type? I shall explain. But say this fault, these circuit breakers are normal circuit breaker. Normal circuit breaker means if they find that a fault is occurred, they will disconnect the equipment from the healthy part of the power system, because circuit breaker basically is a switch. That means the switch will be open. And if the switch is open, then that faulty transmission line will be disconnected from the rest of the power system. This will happen. But the problem is that if this happens, then current that was flowing through the transmission line, power that was flowing through the transmission line will not be able to flow now. As a result, it may be very difficult for the system to maintain synchronism, because a current flow path or a power flow path has been removed from the system. So how the power will flow? Because the generator was delivering power and this power was flowing through the transmission line. Now because now as the circuit breaker see that the circuit breaker is getting signal from the relay. As the circuit breaker is observing that a fault has occurred as given as signal by the relay, it will open the terminal of the conductor, terminal of the transmission line. So transmission line will be disconnected. Now the current or the power coming out of the generator will get no path to flow through the transmission line because this line is not there. Then it will try to flow through some other path. If there are some other transmission line, it will try to flow through some other path. And if it flows to some other path, then those paths again may become overloaded because of the flow of this heavy current or heavy power. As a result, this situation, when overloading is taking place, it may cause the total system to collapse because of the tripping of transmission lines one after another. This type of situation may happen because of the occurrence of a fault. But remember that most of these faults are transient in nature, means they are arcing fault, and this fault has occurred to the surface of the conduct of the insulator from the conductor through the surface of the insulator to cross up. Okay, but if you are having automatic closing feature, that means what is automatic closing feature? If your circuit breaker is such that when it finds that a fault has occurred, it will open the conductor, it will open the switch to disconnect the conductor, and it will wait for some time and then reconnect the conductor. That means after the occurrence of the fault, it will open the terminal of the conductor, wait for a short while, and then again close the conductor. If the arc is removed by this time, that means if the arc path regains dielectric strength by this time, then after the circuit breaker recloses, the healthy operation of the system will be possible, and this will help in maintaining the stability of the power system because now again the power flow path is re-established. But this re-establishment of this power flow path is possible if the circuit breaker is having this feature or this auto reclosing feature. Means circuit breaker terminals will be open first, it will wait for some time and then again close the contact. And this may help the transmission line to continue to flow power which is coming from the generator. Okay, so if automatic closing circuit breakers are available in the system, sometimes it may be possible to maintain the synchronism of the power system, maintain the transient stability of the power system because most of the faults are transient in nature, and for transient fault, auto-declosing circuit breakers may help in improving the stability of the power system. Okay, so could you understand or could you have some idea regarding this feature of the circuit breaker? Why fast fault clearing will improve the transient stability? This should be understood by you, or if you could not understand, please tell me, I shall repeat. Because I have already mentioned in our previous class perhaps regarding the critical clearing angle. Okay, and then whether the automatic closing feature of the circuit breaker, this is also clear to you, and how automatic closing circuit breaker may improve transient stability, whether this is clear to you or not. Let me know this. Anybody? Could you understand this feature? Why fast fault clearing will help improving transient stability? That means why the speed of the circuit breaker and relay are to be very fast. Generally, how much is the speed of circuit breaker and relay? Relays generally will be able to identify the fault within 1 or 2 cycles. Okay, and circuit breaker 5-6 cycles are sufficient generally for the circuit breaker to operate. So this is the time that are achievable by circuit breakers and relay, and therefore you can say that relays and circuit breakers are generally very fast, and as they are very fast, they will actually help the system to maintain transient stability. But why is this requirement there? Why fast fault clearance helps in improving transient stability? Is this clear to you or not? Bolo. Is this point clear to you or not? First, fault clearing, why this is important,
Yes, sir.
and then auto reclosing feature, is it clear to you, or shall
Yes,
it
sir.
repeat? Huh?
Yes, sir.
Auto reclosing feature. Okay, if this is clear, then single pole switching. Another requirement of the circuit breaker is the single pole switching. Actually, circuit breakers may be of two types: three pole switching type circuit breaker and single pole switching type circuit breaker. In power system, we have three phases: A, B, C, three phases, or R, Y, B, three phases. Generally, circuit breaker may be of two types. One is single pole switching type, and that is three pole switching type. Single pole switching type means that phase of the circuit breaker will open where the fault is actually occurred. That means if the fault occurs in phase A, then A phase of the circuit breaker only will open. B and C phases will continue their operation. This is single pole switching type circuit breaker. Okay. And what is three pole switching type circuit breaker? For any fault at any location of the power system, at any location of the system, you say that all the three phases will open simultaneously. All the three phases will open. Okay. That means fault has occurred in all the three phases, then all the three phases will open. Fault has occurred on one phase only, then also all the three phases will open. Fault has occurred on two phases, then also all the three phases will open. So three pole switching type, obviously they will be less costlier, and these are more common because in case of fault, all the three phases will open simultaneously. And single pole switching type means only the faulty phase will open. Healthy phases will continue their operation. What is the advantage of this feature? Advantage is that, say, we have a generator. From the terminal of the generator, we have three-phase transmission line, which is carrying power. Now, a fault has occurred on the transmission line, say at phase A, a fault has occurred. So, what will happen? If we are having single pole switching type circuit breaker, then A phase of the transmission line will be opened, B and C phases will be retained, and power will now flow through B and C phases. And obviously, no power will flow through A phase. What is the advantage? Advantage is that in this case, generated power may flow through phase B and C. That means obviously the full power will not flow, but part of the power will flow through phase B and C. So acceleration of the generator will be less because at least some power is flowing out of the generator, so acceleration will be less. Generator's spool will increase by a smaller amount. As a result, maintaining stability will be better possible. But had the three phases were opened simultaneously, then what would have happened? Generated power could not flow to the transmission line at all. That means there is input power, but output power becomes zero because output cannot flow. Generator cannot deliver power through the transmission line because transmission line has been disconnected. So generator will accelerate faster. As a result, maintaining stability may be very, very difficult. So people switching type circuit breaker, they are cheaper, but they will not be friendly in respect of maintaining the stability of the power system. Rather, single pole switching type circuit breaker, they are obviously costly because three pole switching means only the faulty phase will be open. So mechanism will be required in the circuit breaker. Separate mechanism will be required for opening and closing. But in case of three-phase circuit breaker, a single mechanism will be sufficient to open and close all the three phases together. Okay, but this configuration of the circuit breaker will help in improving the transient stability of the power system. Obviously, there will be another problem. What is that problem? If the power flows through two phases, then there will be creation of unbalance in the system. But that problem may be actually taken care of later. First of all, you should maintain the integrated operation, maintain the stability of the power system. Once you can maintain the stability, then you can sort out other problems. Therefore, or you can say that in respect of severity, maintaining stability is more important. Okay, then maintaining balanced operation. So single pole switching type circuit breaker, obviously they will create some unbalance in the system because power flow through phase A is zero, but through B and C phases some power will flow. So operation will be unbalanced. But this type of operation may be helpful in maintaining the stability of the power system. Okay, could you get some idea regarding this single pole switching type circuit breaker and how they will be beneficial for the system in improving the transient stability? Is it clear? Bolo, is it clear? Because these issues are somewhat complicated, and you should actually, had it been the classroom, then I could actually draw more figure and explain this in a better way. But since this mode of teaching learning has to be employed now we are restricted to. So that's why only by speaking, only by telling you, I can explain now. Okay, could you get the idea regarding the single pole switching type circuit breaker and auto reclosing type of circuit breaker, and what are the advantages of these circuit breakers in maintaining stability? Is it clear to you or not? Bolo. Single pole switching type circuit breaker, could you get the advantage? Why they will be helpful in improving the transient stability?
Yes, sir, understood.
Okay, then high speed excitation control. Actually, excitation control after finishing this stability, we shall be discussing regarding the excitation control. Excitation control basically is the control of field current. Okay. Now, whenever there is any change in the loading of the generator, whether load increases or load decreases, whatever may happen, always the terminal voltage will change. It may increase, it may decrease depending upon the change in the loading condition. And already I mentioned you that the terminal voltage of the generators are generally kept constant. So how it is kept constant? It is kept constant by the action of the excitation controller. The role of excitation controller, the purpose of excitation controller is to change the field current of the generator. Okay. These excitation controller therefore will vary the field current of the generator, and by varying the field current of the generator, they will increase the value of E rather. That means they will increase or decrease the value of E in an attempt to maintain the constant terminal voltage. So, if you have very high speed excitation control, then as soon as there is reduction in terminal voltage or increase in terminal voltage, you can adjust the field current of the generator to maintain the induced EMF accordingly. And this, therefore, will have control on the accelerating power or decelerating power, because with the variation in the field current, peak of the power angle curve will vary. As a result, accelerating power or sometimes decelerating power may also vary depending upon the requirement. Okay, so we will be varying the field current. As a result, the induced EMF will vary. And induced EMF, when in the induced EMF vary, peak of the power angle curve also will vary. If the peak of the power angle curve varies, then available decelerating area or available accelerating area also will be accordingly varied. Okay, and this variation of peak of the power angle curve as a result of the variation of field current or as a result of the excitation control. And this excitation control is very fast. Why this is very fast? Because nowadays these are controlled by electronic or electronic controller. Okay, so they are very fast, and since they are very fast, they can help in system in maintaining the stability also. Okay, so high speed excitation control They are very useful in maintaining the transient stability of the power system. Not only the transient stability, already I have mentioned that this high speed exertion control. While I have mentioned, we have started with the discussion of stability. Then I have mentioned that these exertion controllers are responsible for the problem of dynamic stability. That means where there is a problem of dynamic stability in power system is due to the fact that excitation controllers are there. But again, the improvement of dynamic stability again is possible through the use of this excitation controller also. Okay, so exception controller, they are responsible for the dynamic stability problem. Again, they are also the source of improvement or source of correction of the dynamic stability problem. Similarly, you can say that exception controller, they also are very effective in maintaining the transient stability of the power system. That means you can change the field current of the generator, and depending upon requirement, you can either increase the peak of the power angle curve or decrease the peak on the power angle curve, and hence you can control the available decelerating area and accelerating area, because this decelerating area and accelerating area, they are actually having influence on the transient stability of the power system. We have seen that accelerating area must be equal to decelerating area. So depending upon our requirement in maintaining this transient stability, what we can do, we can either increase the peak of the power angle curve or decrease the power angle curve, peak of the power angle curve, such that stability of the system may be properly maintained. Okay, this is how the excitation controller, the first 16 excitation controller, will help in maintaining stability. Then there is braking resistor. Actually, this spelling is now correct. Brake. Okay, this is not braking resistor. It is a brake. We are using brake. Okay, so braking resistors are all resistor basically connected at the terminal of the generator. They are resistor that they act actually as dummy load. So whenever there is an acceleration of the generator because of the occurrence of some fault, this resistor should be connected or switched on at the terminal of the generator. So they will be consuming power and arrest the increase in speed of the generator, arrest the acceleration of the generator. That means they will act as brake to the increasing speed of the generator, increasing acceleration of the generator. That's why the name is braking resistor. Okay, so they basically act as brake. So whenever the situation is such that the fault occurs in the power system, okay, then because of the action of the circuit breaker, what will happen? The speed, the faulty part will be disconnected. As a result, load will be disconnected from the generator. Generator cannot deliver power to the load. So generator will accelerate. Now, the role of this braking resistor is that they are basically installed at the terminal of the generator. So when this situation is happening, so these braking resistors will be connected at the terminal of the generator through the action of the circuit breaker. As a result, generator will see that as if some load has been connected at this terminal, it will deliver power to the load, that is this braking resistor, and as a result, the acceleration of the generator will be restricted. Acceleration of the generator will be arrested. That means this resistor will be behaving as a brake to the increasing speed of the generator, as a brake to the acceleration of the generator. That's why the name is braking resistor. Okay, so this is again another method by which the stability may be improved. That means some resistors are there. These resistors are basically dummy resistors. They will be operating as load whenever you will be wanting to stop the increase in the speed of the generator. Whenever you will see that it is important to put a brake to the acceleration of the generator that has been occurred due to the occurrence of the fault, we will be connecting this resistor at the terminal of the generator. Generators then will deliver power to this resistor. So this resistor will draw power from the generator. Obviously, they will cause they will do no work. Only power will be lost in this generator. But this loss in power, loss of power through this resistor, will help in reducing the speed of the generator. Will help in putting a brake to the acceleration of the generator, and thus they will help in maintaining the stability of the power system. Okay, that's why braking resistors, you can say that this is a good method for improving the transient stability. Then another method is fast closing of governor valve. Okay, governor steam valve. Basically, what happens? Why the stability problem is occurring? Stability problem is occurring because the occurrence of a fault. Now, if fault occurs, what happens to the generator? If fault occurs, that faulty part is disconnected from the system. As a result, generator sees that there is no path through which it can deliver power that has been generated by the generator. Okay, so power cannot go out when the line is disconnected. Now, input power remains same, but output power becomes zero or very small. So what will happen? Generator will accelerate. But now, if the situation is such that you can reduce the power input to the generator whenever there is a reduction in the power output of the generator because of the occurrence of fault, when power output from the generator decreases, if you can simultaneously reduce the input power to the generator, then obviously then the stability problem will be best managed. That means how you can do this? You can actually then, if you somehow can reduce the opening of the steam valve, then less steam will enter into the generator, less will enter into the turbine, and if less steam enters, power output decreases, or input also is following this. So stability problem will be solved, you can say. So you can say that if this method can be applied, what is this method? With the reduction in the power output of the generator, simultaneously you are reducing the power input from the generator or input to the generator. How? By reducing the opening of the steam valve immediately. But the problem is that this reduction in the opening of the steam valve, it is not that easy. Why it is not that easy? Because it involves high inertia. Okay, steam inside the boiler is having a very high pressure, high temperature. So reducing the opening of the steam valve or changing the position of the steam valve, changing the opening of the steam valve so fast is not easy, is not possible. But if you can somehow bypass the steam, okay, if somehow another steam valve may be opened such that instead of passing through the turbine, this steam is bypassed through some other places, then this may help the situation. Okay, but there is not much success in this method. But if this method can be employed, then obviously this will be the best method for improving the transient stability. So, fast closing of steam valve, generator governor steam valve, basically, it can be the best method for improving stability, but not much success has been achieved here. Or what we can do, we can rather use some bypass valve through which a part of the steam may be diverted in a different path. Instead of entering into the turbine to the steam valve, they will be bypassed to some other places. Then this type of method may work. Okay, so these are the methods generally that may be employed for improving the transient stability. There are other methods. Use of high voltage DC line again can improve the transient stability. Using fax devices, these are not written here. Using fax devices, flexible AC transmission system. What is this HVDC line? Because you know that HVDC lines are there along with high voltage DC lines. There are HVDC lines. Why HVDC lines or high voltage direct current transmission, it can help transient stability because control of power is very fast through converter. Okay, it basically DC line they use converters. Okay, the converters control is very fast. How fast? Within one cycle, you can control the converter. That means you can increase the power flow or decrease the power flow through a transmission line. Through this transmission line within one cycle, within half a cycle rather, because all control of the thyristor or all control of the converter that has to be completed within half a cycle because you have to employ symmetrical control on both halves. So any control that has to be completed within half a cycle, and that also is possible to be completed within half a cycle. That's why control of power is very fast when HVDC lines are used. In AC, these are not that fast because in AC you have to use the auto transformer, you have to use the phase shifters. Okay, these are required for control of power flow. But in DC, these may be obtained with the help of converter operation. And converter control is very fast. That's why when high voltage DC transmission system is used, then since the power flow control may be obtained, may be employed very fast. Therefore, the transient stability problem also may be improved by using HVDC transmission system. But nowadays, when HVDC lines are not used, there are fax devices available. These fax devices are power electronic controller again. They are actually used in AC line, AC system, but they are through the use of this fax controller, this power electronic based controller, you can employ first control of power also. Well, that means instead of using conventional phase shifters used through phase shifting transformers or conventional changing transformer, you can use these power electronic devices to have a faster control of power, faster control of voltage. Okay, and when these controllers are used, transient stability also may be improved. Transient stability problem of the system also may be improved because these controllers are very fast, and speed is very much important whenever you are talking about the control of stability problem. That's why use of high voltage DC link and use of flex controller both help in improving the transient stability of power system. Okay, so these are the issues, these are the methods for improving the transient stability. Now, if you have any questions on whatever I have discussed today, you can make me, you may have doubt, but ask me regarding your doubt, then I can try to explain it further. Okay. Any doubt, any question regarding the methods for improving transient stability and also for steady state stability? Bolo. So if you have no other questions, then we shall stop here because these are the methods for improving transient stability. And this is what I had to discuss regarding stability. So I have one more topic to be discussed, that is regarding the excitation control system. Excitation system that I shall start in the next class, therefore. And regarding the stability problem, okay, if you are having any doubt, any questions, then that also I can continue in my next lecture. So what is left regarding, it is left to discuss regarding the excitation system, and another thing is left. We have not solved problem regarding on uh, frequency control. I shall be discussing some problem on frequency control that I shall do. Okay, so in our next class I shall be discussing the excitation control system, and then when it is over, I shall be discussing discussing other problems related to frequency control. Some numerical example I shall discuss. And if you are having any questions, any doubt over the whole con- content I have discussed so far, that also we can discuss in those classes. Okay. So if you are not having any questions, then I shall make no call today, or you can ask me if you are having any doubt. Okay. Now, Ali Hamzan,
Present, sir.
Omrita Dotto,
Yes, sir.
Anirudh Anand,
Yes, sir.
Pankit Jaiswal,
Yes, sir.
Arijit Pal,
Yes, sir.
Kaushik Maji,
Present, sir.
Mujahid Alam,
Present, sir.
Parvez Musharraf.
Yes, sir.
Okay, you are present, but I can sound was very less. Okay, very small. So Shreyas Khatri,
Present, sir.
Mohammad Sohail, Mohammad Sohail, Somnath Pal, Showdeep Sen.
Yes, sir.
Showdeep is present. Then Sukesh Murmu,
Yes, sir.
Swapnil Kisku,
Yes, sir.
Ujjwal Haldar.
Yes, sir.
So anybody who could not respond, Mohammad Sohail or Somnath Pal, or anybody? Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.